What does the CBC have to do with architecture? In this episode of Lab Stories, you're going to find out. Welcome to Lab Stories, where we help you understand your labs and optimize your health. In each episode, we're going to bring a lab to life using stories, clarify the most common abnormalities, teach you what matters, what doesn't, and show you how to move from the red to the black. I'm your host, Dr. Tom Schexnayder. Let's go. The CBC is all about architecture. It's a numerical and structural analysis of the three blood cell lines. It's all about quantifying what you see when you look under a microscope. Because remember, there are tons of molecules in your blood, but when you look under a microscope, you can see three. And those three are what I'm going to talk about today: red blood cells, white blood cells, and platelets. Let's start with the story. Imagine the bone marrow building company has just won the bid for a prestigious new residential development in your town. This is no ordinary neighborhood. It'll have houses, restaurants, shops, and even its own police force. And it'll be built in 4 distinct phases. There'll be regular-sized homes and even an estate section. The homes represent the red blood cells. Seeing a normal number and structure of red blood cell houses implies that the building company had all the workers and supplies it needed to get the job done right and on time. The white blood cells are the police force. They're a coordinated, diversified team that keeps the whole neighborhood and the rest of the city safe. They have neutrophil city cops with a K9 unit, lymphocyte FBI, monocyte crime scene cleanup crew, basophil mall cops with walkie-talkies and pepper spray, and even an eosinophil space force. To maintain the neighborhood and the city infrastructure, Platelet Brothers Plumbing has it covered. This scene will be the basis of the next 3 episodes, where we first dive into the process of red blood cell home building and all the things that go wrong with the supply chain. Then we'll learn about the police force, which I agree for a neighborhood is pretty over the top, and comment below what you think the HOA fees will be for this place. And third, we'll cover the municipal supporting services, including Platelet Brothers Plumbing and the concrete coagulation cascade. If you have CBC results, go ahead and pull them up now so you can pause the episodes and reference this stuff in real time. The first CBC was done in 1852 when someone put a drop of blood on a microscope slide and counted the cells they saw by hand. Over the years, technology evolved, and of course, CBCs are now automated by machines using a variety of techniques to count cells, measure their sizes, and determine their types. And here's a little bit of nomenclature. Cyte means cell, and the cells are named based on their color. Red blood cells are erythrocytes. Erythro means red. White blood cells are leukocytes, with leuc meaning white. White blood cells, interestingly, are actually colorless, but when blood is spun down in a centrifuge, white blood cells form a white, buffy coat between the red blood cells and plasma. It's white, thus they're called white blood cells. Platelets are also called thrombocytes, with thrombo meaning clot, and the word platelet itself is defined as a small, colorless, disc-shaped fragment. So now you know the history of the CBC and what the cells are called and why. And as I've learned through my medical training, and you will learn through this podcast, things in medicine are usually named based on a historic observation that may or may not still be relevant. So names may seem like they make no sense unless you look up the etymology of the word. Okay, so I mentioned that the CBC is all about architecture and measures red blood cells, white blood cells, and platelets. There are 20 line items on the CBC, and they can be put into 4 main categories. I'll go through them individually now and have your CBC out for reference. Number 1 is cell counts. This is easy to understand. The cells of each type are counted, and that number is reported. Since the cells are floating around in the blood, the units used for cell count is number per microliter, and a microliter is 10 to the negative 6 liters. You can see right off that red blood cells are by far the most numerous, and that has to do with their function. They carry oxygen, which is the fundamental human life-sustaining molecule. They number in the millions per microliter. Platelets, which play a role in blood clotting, are in the 150 to 400,000 per microliter range, and white blood cells, which function in immunity, are in the 4 to 11,000 cell per microliter range. Those are the absolute cell counts, and they're widely discrepant in terms of the 3 cell lines. For leukocytes specifically, relative or percentage counts are also reported, and this is because there are 5 types of leukocytes. In order of normal descending amount, they're memorized by the silly mnemonic, "Never let monkeys eat bananas." Neutrophils are around 60%, lymphocytes around 30%, monocytes at 5%, eosinophils around 2%, and basophils about 0.5%. Different cell types, different counts, absolute and relative. That does it for cell counts. Number 2 is cell sizes. And FYI, cell sizes are measured only with red blood cells and platelets. White blood cell sizes are not reported. And I've used the term sizes very loosely because it's easy for us to understand. But when I say size, I'm really invoking 4 scientific measurements. Number 1 is mass, which we'll consider interchangeable with weight and used in mean corpuscular hemoglobin, which is the average amount of hemoglobin in each red blood cell, measured in picograms or 10 to the negative 12 grams. And the word corpuscle is an excellent example of the historical naming principle I referenced earlier. Corpuscle is just an old word for cell. Number 2 is volume, which is the amount of space an object occupies. We see this in mean corpuscular volume, which is the average volume of a red blood cell, measured in femtoliters or 10 to the negative 15 liters, and hematocrit, which is the percentage volume that the red blood cells take up compared to the total blood volume, and mean platelet volume, which is the average size of a platelet, also measured in femtoliters. Those are all volumes. Number 3 is concentration, which is mass per unit volume. This is used in hemoglobin and mean corpuscular hemoglobin concentration, both measured in grams per deciliter. MCHC is actually hemoglobin divided by hematocrit, which now just sounds like we're doing math gymnastics, but since hemoglobin is a concentration of grams per deciliter and hematocrit is just a percentage, the units grams per deciliter stay the same. Okay, number 4 is variance, which is a statistical measure of how much data sets deviate from the mean. And this is used in red cell distribution width. The bone marrow, under normal conditions, should produce red blood cells that are almost the same, but they're not clones. High RDW indicates a production problem, and low RDW is actually not associated with any pathologic processes. If those 4 measurements were confusing, just forget about that and let me simplify cell sizes for you once and for all. We mainly care about red blood cell sizes because red blood cells are essentially cargo barges. They float passively through the blood carrying oxygen, so all that matters is what their structure is, since structure directly determines how much oxygen they can carry. So we have 3 categories of measurements. Number 1, the overall oxygen carrying capacity of the entire group of red blood cells, which are hemoglobin and by extension hematocrit. Number 2, what the average red blood cell can do, which are the mean measures MCV, MCH, and MCHC. And number 3, how the cells compare to one another, which is red cell distribution width. It's normal to have some variance in cell sizes. Some are a little smaller or bigger than others. We just know there's a quality control sweet spot, if you will. Too much variation expressed as a high RDW implies a deficit in the manufacturing process that I'll talk about next episode. Okay, I know that was a lot, but just to recap number 2, we care about red blood cell and platelet sizes, what the whole group can do, what the average cell can do, and how the cells compare to one another. Cell counts, cell sizes, and number 3 is cell contents. Hemoglobin is so important that I created this category specifically for it. Hemoglobin is the thing that actually carries oxygen in red blood cells. And let me explain. Hemoglobin is a metalloprotein that contains 3 things: 4 peptide subunits, each containing a heme molecule bound to a central iron molecule. And follow me here. Iron binds oxygen. Heme contains iron. Globins are attached to heme. That is hemoglobin. And hemoglobin makes up 95% of red blood cell mass. Hemoglobin literally tells you how much oxygen your red blood cells can carry. So the first step in interpreting a CBC is looking at the hemoglobin. The other capacity measures, if you will, are helpful only if the hemoglobin is abnormal and you're trying to figure out why. So the CBC reports out cell types, red blood cells, white blood cells, and platelets, cell counts, how many there are of each cell type, both absolute and percentages, cell sizes, which really means mass, concentration, volume, and variance, and cell contents, with the underlying question being, what is the oxygen carrying capacity of red blood cells, which can be boiled down to one thing: hemoglobin. Compared to the red blood cell cargo barges, which just carry oxygen in a static structural role, white blood cells and platelets play active, functional roles in immune defense and blood clotting. And this is where it gets tricky. Looking at white blood cells and platelets through a microscope is like looking at a car and making a judgment about how it works. You can't directly determine function. If it looks like a Corvette, you're pretty sure it goes fast, but you don't know 100%. If it's a big truck, it can probably pull a heavy load, but again, maybe it can. You just don't know for sure. And that's the fundamental limitation of white blood cells and platelet counts on the CBC. Nonetheless, the data we get from the CBC about them is very interesting and helpful. All right, my brain is fried, so I'm gonna go ahead and wrap it up here. Now that we have a good overview of the CBC, the next 3 episodes will cover the individual cell lines using this crazy neighborhood story that involves supply chain chaos, the mafia interference, crazy police force, and all sorts of other good stuff to help you understand your CBC and optimize your health.